All right, y'all, about to get y'all ready on 8.3. So we'll do 8.3 and then we'll do a little bit of 8.4 today. So 8.3 is pretty short. Y'all ever done synthetic division? Long division? We won't be doing long division though, but we'll be doing synthetic division. So 8.3 deals with polynomial division. And we're specifically going to be looking at what we call synthetic division. Okay, so I can use synthetic division for three things in here. I can use it to find function values. So if I use synthetic division to find function values, the remainder will equal the function value. Okay. Another thing we'll use it in here for in college algebra is to check whether a number is a zero or not. So I can determine if a number is a zero. And y'all remember, zeros are basically the solutions you get when you set the polynomial equal to zero. Zeros are also where they cross that x-axis at, okay? If a number is a zero, then the remainder of synthetic division will be zero. Is zero. And so if I'm checking my numbers, I go through and I get a zero remainder, then that means that that number is a zero of that polynomial. Any other value for the remainder, then I'll put a note for that, okay? Now, if you got support class along with the college algebra, this third method you'll be doing in it, and it is to find a quotient and a remainder. So I can find quotients and remainder. Okay, so college algebra, we're just going to focus on function values and then determining if it is a zero or not, okay? So let me put my steps for synthetic division. So I'm going to let y'all write the first three things down real quick, and then I'm going to use that. I'm sort of going to work an example while I put my steps up here so that y'all can see what I'm actually doing, because it's got a few steps, but a lot of it's repetition. So it sort of gets me having these cameras. You can only use so much of these boards. Any of y'all go out of town for the break? Beaches?
We went to Houston and Galveston.
Oh, okay. So was it crowded?
Not really.
Was it
There's
not?
been records the week before ours.
Wasn't like Miami, huh? They were showing Miami on TV, whatever. All right, so let me erase this and I'm gonna work an example while we're doing this. So let me write this one up here. Oops. Oh, there. I'm going to use synthetic division to find the function value. All right, I'm going to start with f of x equals x to the third minus 12x squared plus 41x minus 30. I'm going to find f of 1. Now, in the past, if you wanted to find f of 1, you just put a 1 in for all these x's and then you figured it out. This is another way to do it, and that's using synthetic division, okay? So, I'm still going to write my rules out while we work this problem. So the first thing you do on synthetic division, you write out the coefficients. All right, so the coefficients are your numbers in front of the variables. So I got a 1, negative 12, 41, and a negative 30. Now, the trick on this, you have to use zeros for any missing terms. So what I mean by that, I've got the x3 as my highest term. I got an x squared term, an x term, and then my constant term. So I wasn't missing any of these, but if I was missing one of my terms, I'd put a 0 there, okay? All right, underneath these coefficients, I leave a little space, and then I'm going to draw a box under here. So then I just draw the box. Under the coefficients. Okay, that's the first thing. Second thing I'm going to do, I write C. So what I do on C is I put me a little half box right here. And C is going to equal the number you're finding the function value for, which in my case is a 1. So I'm going to put a 1 right there. So what's that, half a box? Any of y'all ever done this? I'll bring back memories once I get going through it. Now, function value for f of 1 will be whatever I get in that remainder box. All this under here would be the quotients that you would get, because basically we're dividing this. Now, support will ask you for the coefficients and stuff. We don't have to worry about them in here. All we're looking for in this class is what's in that box. Okay? All right, you're going to bring the first number down. So bring the first number down. What I mean is this 1 is going to come all the way down into my box. So now, this is where you start seeing all the repetition. Numbers that are down in this box, multiply by the C to get me the next column's number, okay? So I'm gonna multiply 1 times 1, and that gives me a 1. So, multiply the number you brought down by the C, and place in next column. Okay? So multiply by the 1 from a C, got my answer with a 1. Now you add the column. Add the new column. So a negative 12 plus 1 is going to give me what, a negative 11? So negative 11 is now my second number in the box. Take that new number and repeat the process. So now you'll take negative 11 times 1, which is negative 11. So repeat the process of multiplying, adding and multiplying until completed. Okay, so 41 minus 11 is what, 30? So that 30 comes down. I still got spaces, so I'm going to now repeat the process. 30 times 1 is 30. And then what, negative 30 plus 30 gives you a 0 remainder. So that means f of 1 equals 0. So if you put a 1 here, that's 1, right? 1 times 1 times 1. Minus 12 times 1 plus 41 times 1 minus 30. So 1 minus 12 is negative 11, plus 41 is 30, minus 30 is 0. So these synthetic division remainders give you the same answer as if you put that 1 into that equation, okay? Sort of exciting, right? Questions on that? Then I'm going to do about 4 or 5 problems of synthetic division. Okay? And it's just a repeated process over and over. All right, so I'm ready to rock and roll on some synthetic division then, right? Also, I put calculator programs on them calculators y'all got. Hit program and go all the way down to send div. And as I'm doing this next one, I'll tell you what to do on that calculator. All right, so I'll do the same thing, use synthetic division. Define function values. All right, y'all, this one I got f of x equals x to the 4th minus x to the 3rd minus 15x squared plus 31x minus 36. I'm going to find f of a 5. Now, I will say this, if you was doing this by hand and just plugging in 5s into them x's, that x to the 4th means 5 times 5 times 5 times 5. That's going to get pretty big numbers on you. For the synthetic division, I can keep it all fairly small numbers on that thing. Okay? So, Now, on your calculator, the first thing it asks you on synthetic division is the degree. The degree is equal to the highest exponent. All right, let's write down my numbers. My coefficients are going to be a 1, a -1, a -15, a 31, and a -36. All right, let me draw my box. And I want to square my remainder because that's going to be the answer. And my C will be this time a 5 because I'm finding f of 5. So, same thing I did here, I'm going to do on this one. We're going to bring the 1 straight down. Now, if you look on yours, it's going to ask you, go to your program. Oh, I never did plug mine up. I need to give you more. That's why I didn't have a good calculator that day, so. You got the. Or maybe you had one over there, past that one, I don't know. I don't know. All right, it's already got 10 days on it.
No, the batteries are dead on this unless I don't turn on.
A little corroded on Let's go to that program. You go down to 10 6. So it's going to ask you the degree. The degree is the biggest exponent you see, which is a 4 on that. So you'll do 4 in there. It's going to ask you for the coefficients, which is the 1 inner, -1 inner, and so on. See, when you put in the degree, it tells it how many numbers it needs. It always adds 1 number to the degree because it got 5 numbers there. All right, so y'all ready? Here we go. 1 times 5 is 5. Then let's see, once you put their numbers in, it's going to ask you for the C, which is 5. There you go. Now, those numbers right there are going to be these numbers I get under here. Those are technically the quotient if you were to divide by that. Now, if you want the remainder, you hit enter one more time. So what's that giving you?
2. I think it says C.
You're wanting 244.
Okay, 244.
So what this is saying, if we got some of these questions will have 2 numbers for you to check. If I want a new C, I just hit 2 enter, and then I can put the new number up there. Like if I was finding, say, f of 5 and f of 6, you would hit 2 enter, put the 6 in, and then it would run it for you. All right, so let's see. -1 plus 5 gave me a 4. So these will start matching those coefficients you had the first time. 4 times 5 is what, 20? 20 minus 15 gives me 5. 5 times 5 is what, 25? Let's see, 31 plus 25 is what, 56? 56 times 5, I think, is 280. And then 280 minus that 36 gives me 244. So first time you go through it, it's going to give you the quotients, which are these numbers. Then it gives you the remainder on that program, which is what you're looking for. So I know now that f of 5 equals 244. That's the same answer I would have got had I put a bunch of 5s in for all these x's and tried to do order of operations on it, okay? All right, so now let's check for zeros. This next one, same thing, it's just going to look for zeros. If it's a 0, it'll have a 0 remainder. You'll put yes. Any other remainder, you're going to put no, okay? So I'm going to determine if the following numbers are zeros. I'm going to check -5 and 2. The polynomial is f of x equals 3x to the third plus 10x squared minus 19x plus 30. Now, y'all, I will say this about these zeros. These zeros have to be factors of that last number. So these are both possible zeros because 5s and 2s are both factors of that 30. So they got to be factors of that number, but that's not guaranteeing them to be a 0 or not, okay? So we'll run synthetic division and look for some 0 remainders. So let me write my coefficients. I've got me a 3, 10, -19, and a 30. Now this one, when it asks you for the degree on this one is a 3 because that's your largest exponent. Okay. All right, so the first C I'll check is going to be the -5. Again, you always repeat that process now. So the 3 comes straight down. Multiply that 3 times -5. That's going to give you -15. 10 and -15. Give me a -5. So first number always comes down. Then you start multiplying to get the next column. Add. Multiply again. So now I got a -5 times -5. Oh, that's what a positive 25. 25 and -19. Give me a 6. And then finally, 6 times -5 is what, a -30. And then you add the 30 and -30 and get a remainder of 0. So this one would be a, yes, that is a 0, okay? That means that graph crosses over that x-axis at that -5, okay? So this one would be the one where you work it through and then it asks you for new C, hit 2, you would do 2 enter, and then all you would put in is the 2 for the next number, okay? And then it'll spit out the next set of numbers for you, and did yours ever get one?
No, what if you take it home and
Okay.
I'll bring it back though.
Little bit of erosion in there, wasn't it? Now, I'll write the same coefficients, which is a 3, 10, -19, and a 30. This doesn't make too bad though.
Yeah.
I'm gonna do the same thing, bring that first number down. So that 3 comes all the way down. And then we just start multiplying and adding. So 3 times 2 is 6. 10 plus 6 is 16. 16 times 2 is 32. Oh, let's say 32 minus 19, that's like 13. 13 times 2 is what, 26? So that's gonna give me what, 56? 56 is not a zero, so this number is not a zero, and you would put no. But be careful because they put them in order of the numbers they're using. It'll be like yes, yes, no, no, yes, or something like that on the answers. So just be careful.
Can I ask you?
Mhm. Okay, some questions on that one? Well, no, that's the main thing A3 is, so let me break out the good one then. Is 1/2, so I'm gonna break out a fraction, a zero of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2. Alrighty, so we got fractions, but that's all right. At least in this section, they kept us all common denominator, so it shouldn't be that bad on y'all. So let's see. Let me write my coefficients. I got a 1, a 1/2, 5/2, and a negative 3/2. So I'm still looking for C if these are zeros, so I'm still looking for a zero remainder on that. My C is the 1/2 that they're wanting me to check. So y'all, it's a good thing everybody's got a 2 on the bottom, okay? So we're still gonna bring the first number down. So bring that 1 down. Now this ain't bad. 1 times 1/2 is a 1/2. So when I add these fractions, the bottom will stay 2, everything gets added on top. So that'd be what, a 1 plus 1 on top is 2. 2 over 2 equals. So no, 1/2 plus 1/2, that'll give me a 1. Multiply again, 1 times 1/2 is 1/2, which we now bring under the 5/2. So 5/2 plus 1/2 gives you 6/2. 6/2 is equal to. There we go. Now, 3 times 1/2. So remember, these fractions, you're just multiplying straight across. 3 times 1/2 is just going to be a 3 over 2, okay? So that gives me a 3 over 2 there. Well, look at that, negative 3/2. Positive 3/2 gives me a big O. 0 remainder, which means yes, 1/2 is a 0. Okay, so those ain't too bad. Stuff I'm about to do might be a little trickier. So I think there's like 4 or 5 problems only in 8.3. Doing this kind of problems like this did, okay? So I'm gonna catch up, and then when I got 8.4 stuff, not all of it, just a start on it. Now remember, I warned y'all about some foiling coming up though, right?
Yeah.
I said we'll be doing a lot of foiling in chapter 8. Well, today is the day. So y'all have practice. Have y'all ever foiled imaginary numbers? Radicals? We will today, y'all watch. Here we go. So 8.4. 8.4 is theorems about zeros. And theorems are sort of like laws and stuff. But we ain't gonna worry about all that. We won't be worried. We'll just be doing a lot of foiling and a lot of synthetic division, okay? Alrighty. So, to find a polynomial given the zeros. First thing I do is I set each zero as an equation. So what I'm saying is if they gave me three zeros like 1, 2, and 5, I'm going to set up my equations. X equals 1, X equals 2, X equals 5, okay? We're going to be working in reverse from when we would solve an equation. We're going to start with the solutions and work backwards to get the actual polynomials. So set up equation using zeros, get 0 on the right side of each equation. So if you had something like x equals 5, you would subtract 5 from both sides so that you would have x minus 5 equals 0 at that point. Put everything in parentheses, equal to 0 still. So I'm going to put them in parentheses, like if I had x minus 5 equals 0, I'm going to put x minus 5 in parentheses, my x plus 2, and whatever else I get, okay? Multiply field up. A lot of multiplying here is going to be the multiplying we call FOIL, okay? Let me, something happened to my signal. Oh, wow. Monica, I might not be able to show my stuff on the screen. I'm getting an error on my camera. But I sent out videos earlier today that went over these lessons for 8.3, and I'll send out one for part of 8.4 that I did. Wow. Yeah, so. All right, so here we go. I'm going to find a polynomial of degree 3. That has zeros of -2, 3, and -6. All right, got it back. All right, Mike, we're back online. All right, so I got 3 zeros, and I will say this: when you do these problems, the number of zeros they give you is going to equal your highest exponent when you're done. Okay, and that's what on this one they're telling me it's going to be a degree 3 polynomial. So set up equations using the zeros. So I got x equals -2, x equals 3, x equals -6. And then I said you want to get a 0 on the right side of all these equations. So since that's -2, we would add 2. So I get x plus 2 equals 0. Then I would subtract 3 from the next one. And x minus 3 equals 0. Add 6 to the last one. And you get x plus 6 equals 0. So see how we're working in reverse? Now, I'm going to put all these in parentheses and set it equal to 0. I'm going to have an x plus 2, x minus 3, x plus 6, all equal to 0. And the reason we can do that is because all 3 of these equations were set equal to 0, okay? So y'all, that's where I'm at now. Multiply until you're done. So usually on these, I take my last 2 and multiply them. So I'm going to just sort of FOIL these. So that I get my x plus 2 times whatever that gives me. So on the side, I'm just going to FOIL this real quick. Which is what? X minus 3 times x plus 6. All right, so doing that, you get an x squared plus 6x minus 3x. Ooh, what's that? Minus 18. And then I'm just going to add those middle terms together so that that gives me an x squared plus 3x minus 18. So I'm going to put that right here now. X squared plus 3x minus 18. So I just sort of go through and FOIL 2 of them at a time. Now you got 2 things times 3, so you're going to FOIL this again. But everything's getting multiplied 3 times this time. The x is going to multiply by all 3 of these. Then that 2 is going to multiply by all 3 of those, okay? So x times x squared gives you an x to the 3rd. X times 3x is a 3x squared. X times -18 is a -18x. So I distributed my x. Now I'm going to distribute my positive 2. 2 times x squared is a 2x squared. 2 times 3x is 6x. And then 2 times -18 is a -36, all equal to 0. So at this point, the only thing we can do is add like terms and be done. So my like terms are going to be these x squared terms right there, and then my x terms right there. So bring down that x to the 3rd. Which y'all, I'd be happy with that x to the 3rd in the beginning because that is a degree 3 polynomial now. Let's see what 3x's plus 2x's squared is what? 5x squared. Now, what you got to remember when you're adding like terms, you don't change those variables a bit. You only can change the numbers in front, okay? So the -18x plus 6x is what? A -12x. And then at the end is a -36. So on this one, on the first one you do in this section, you see where I got the 5 underlined? They give you everything but the 5 on that question for the answer. So after you figured it out, you just put 5 there and be done. Now some of these, they'll make you write the whole polynomial. But some of them, they'll have certain parts that you just put in the 5, or they might have wanted the -12 or something like that, okay? All right, so I'm about to bring out memories on imaginary numbers first, and then maybe radicals, okay? So pulling ain't too bad after you get used to it a while. All right, here we go. Find a polynomial. And then some of these, they don't tell you what degree you're going to end up with. They just say like find a polynomial of lowest degree or something like that. But I'll tell you, the degree is always going to equal how many zeros you got, okay? So same thing, zeros of 3, 6i, and a -6i. Now, on these, in this section at least, anytime you get imaginary numbers, you're always going to have its opposite. So if you got a positive 5i, you're always going to have a negative 5i and vice versa, okay? Those zeros always come in what we call conjugate pairs. Okay? All right, so first thing we'll do is set each of these. X equals 3, x equals 6i. X equals -6i. Then I'm going to move them all over and get zeros on the right side. So I'm going to subtract 3 so that I get an x minus 3 equals 0. And then same thing with imaginaries. Subtract 6i. And really, if you notice that all I'm doing to these numbers is changing their signs when I set them up equal to 0. That was a -6i, so I'm going to what? Add a 6i. So I get x plus 6i equals my 0. Okay? Then put all these in parentheses and set it equal to 0. So let me give you a little clue on this one. When they give you imaginary numbers, start with the imaginary numbers on your FOIL. You're committing suicide if you start with these two in the front. Okay? Because the nice thing about conjugate pairs, when you multiply conjugate pairs of imaginary numbers, you get rid of the imaginary numbers. So I'm going to FOIL these two first. So let me put that on the side here. Oh, what was that? X minus 6i times the x plus 6i. So watch how they turn into just numbers instead of the I stuff. I'm going to start out with the x times x, which is an x squared. I'll then do the x times 6i, which is a positive 6ix. So then I'll start distributing the -6i right here. -6i times x is a -6ix. And then at the end, -6i times 6i is a -36i squared. But what's happening in the middle? What happens to the 6ix and the -6ix? They're going to cancel. There you go. So the only other thing is, y'all got these calculators right there? See what I squared equals. And the I is down there by the 0, you hit the blue button, and then the 0 to get the I, now square that. You can either get that x squared one, or you can do that in. So what's I squared equal? -1. Which means this I squared is really a -1. So when you multiply that -1 times that -36 at the end, this will make it a positive 36. This I squared will always turn your negative number into a positive. So that I end up with an x squared plus 36, okay? And y'all, if you would punch this in -36 I squared, it would actually give you the positive 36 on that, okay? So I know that's what this equals, but notice all the i's are gone. Okay? So I now have my x minus 3 times my x squared plus 36, all equal to my 0. Now, here's the thing about this. Anytime you FOIL imaginary numbers, it's got to end up positive on there. It's going to be an x squared plus 36, x squared plus 49. Imaginary numbers always end up being positive, okay? All right, now I get to FOIL again. But notice, at least I only got 2 things times 2 this time instead of 2 things times 3, okay? All right, so here I go. X times x squared is x to the 3rd. So remember on my x's, I'm just adding those exponents up, right? X times 36 is a positive 36x. Then we start distributing that -3 through there. -3x squared. Woo, okay, y'all figure this one out. -3 times 36. 108? And all that's equal to my 0. So there's no more multiplying I can do. There's probably only one more thing I might do to that. Just rearrange them x squareds and x's around and put them all in what we call descending order. So that I get an x to the 3rd minus my 3x squared plus my 36x minus the 108 equal to my 0. Now, usually all you're going to put in is a polynomial. You don't have to probably put in the equal 0 part, okay? Some of them, like I said, they'll have blanks where you'll put in the missing numbers. Like on this one, I think the one I just did, it would have asked for this number, and that number. Like it should be like y'all's number 2 on there. Then number 3, they give you like a multiple choice of the 4 different polynomials you get. So let me try down there. No, imaginary. How about radicals? So this one, my zeros of square root of 3, negative square root of 3, and 5. So I'm going to be picky on this one. I don't want to start out with my radicals first. So I'm going to put the 5 first. Then I'll put my x equals square root of 3, x equals negative square root of 3. I try to keep the stuff I'm going to FOIL first on the right side. So that way if you got 3 things, you'll still have the 2 things in front instead of the 3 things in front, okay? All right, move everything to one side, get them zeros. So I got my zeros, and I'm just gonna put everything in parentheses and get ready to FOIL them, okay? Okay, here I started with imaginary. But you know, imaginary numbers are really radicals. They're just radicals that have negative stuff under them instead of positive stuff. Okay? So we'll start with those radicals first. So I'm gonna work that on the side. X minus square root of 3, x plus square root of 3. So just like the imaginary stuff, when you FOIL radicals that are conjugate pairs like these, the radicals go away. Now, let me ask you all one thing. Recall on radicals that any radical times itself equals what was under that radical. So what that means, if you had square root of 5 times a square root of 5, that would be a square root of 25, which is 5. Okay? I just say that because here you got radicals going to multiply by each other, okay? All right, here we go. We got an x times x is an x squared. X times square root of 3 is a positive square root of 3x. Notice I didn't put the x under the radical. Numbers under a radical cannot multiply by stuff that's not under a radical, okay? So you just put the square root of 3 and then the x is right by it. But it's not under that radical, okay? Negative square root of 3 times x is a negative square root of 3 times x. And then negative square root of 3 times a positive square root of 3 is a negative square root of 9. See, those 3's can multiply because they're both under the radical. So if you notice right here, those cancel again. So then I get an x squared minus, what's square root of 9? So I get an x squared minus 3. So y'all notice this. When you FOIL imaginary numbers, they're always positive. It's going to be x squared plus something. When you FOIL radicals, it's always going to be x squared minus the number, okay? Radicals always equal minus. Imaginary is always equal to positive, okay? All right, so that now can go into my equation. So I got x minus 5 times x squared minus 3, all equal to 0. And what's nice about this is you got 2 things times 2, so FOIL this and be done. So x times x squared is x to the 3rd, which we knew our highest degree was going to be a 3 because we had 3 zeros, okay? X times negative 3 is a negative 3x. Negative 5 times x squared is a negative 5x squared. Negative 5 times negative 3 is a positive 15, all equal to 0. You know, once again, there might be one more thing I'll do to that, and that's be switch them around a little bit, right? So that I get an x to the 3rd minus my 5x squared minus my 3x plus 15. Okay.
Would it matter if you put it in
No, on this one they had an A, B, C, D choice. So the only one that would have been the right numbers would have been the one they had. And I think they're putting them all in order. They automatically will put them in order. So they had that answer. Some of these they had X4s on. Well, hell, we don't got the 3 zeros, so there's no way you'll ever get an X4 on those. Some of them got like 6x3. They got numbers mixed up and stuff on them, so. Now, it should take these in any order you're putting them in, unless they say put them in descending order. If they specifically say that, then you got to sort of keep that going, okay? All right, so I'm gonna do this next. I'm gonna show you all tricks I do with this. Because it had fractions, so zeros of -1/5, 0, and a 4. Well, now, I will say when we come back next class, listen to this one. Find a polynomial degree 6. So that means we could be falling 6 times on something like that, right? Oh, so this is not bad. I got x equals a -1/5, x equals 0, and x equals 4. And let me show you a trick I would do to this one. Let's get rid of the fraction first. To get rid of this fraction, I will multiply both sides by 5, okay? So I'll multiply both sides by 5, so that I get a 5x equals -1, okay? Because if y'all were solving this, ain't that your last step you do is divide that by 5 to get the -1/5, right? Now, to get a 0 over here, I'm going to add a 1 to both sides. So I get 5x plus 1 equals 0. So if you start with a fraction, your factor is going to be a number in front of the x, okay? X equals 0, can I do anything to that? No, it's already got a 0 over there, don't it? And then that x equals 4, I'm going to subtract 4 from both sides, and I get x minus 4 equals 0. So notice my factors are going to be 5x plus 1, x, and x minus 4. Anytime you got single x's, put them in front. And then put in your 5x plus 1, and then your x minus 4, all equal to 0. So notice the x equals 0 gave me a single x on that, okay? Those are the ones I love. I would love that if that was an extra equals 0, because to do that, what all you're doing is distributing them last, okay? So watch this. We're going to FOIL this. So that'd be my side work on this one. 5x plus 1 times x minus 4. Okay, so let's see what we get. That's going to give me 5x squared. Minus 20x plus 1x minus 4. I'm going to add my like terms in the middle, so I get a 5x squared minus 19x minus 4. I'm now going to put that right here. 5x squared minus 19x minus 4, all equal to my 0 still. Now, the reason I like this one, anytime you got x is equal to 0, x squared is equal to 0, I don't have to FOIL this. All I got to do is distribute that 1 extra there. So x times 5x squared is a 5x to the third. All we're really doing is adding 1x to everybody, right? So now X times negative 19x is a negative 19x squared. And then x times that negative 4 is a negative 4x. All equal to 0, and then that one's already in descending order, so we're good to go. So y'all, the fractions look ugly, but if you'll do them like I did here, get rid of the fraction and then add your number, it's better than trying to FOIL stuff with a 1/5 in there, okay?
By multiplying by the denominator.
Mm-hmm. Mm-hmm. You'll see this side, the 5's cancel, and then that side, that puts the 5 on the other side. Whew, I'm gonna try to start this one, but we might not finish this one, okay? But some of y'all like to work ahead, and I'll show you what they mean by certain words here. They're telling me this will be a degree 6. So it's going to be a degree 6. The zeros are, so negative 2 is a 0. Multiplicity 3. Zero is a 0. Multiplicity 2. And then 2 is a 0. Multiplicity 1. So, multiplicity means how many times you have that 0. Okay? So since negative 2 is a 0, multiplicity 3, that'll be like x equals negative 2, x equals negative 2, x equals negative 2. 0 is a 0 multiplicity 2. That means x equals 0, x equals 0. And then it tells me 2 is a 0 multiplicity 1. So that'll just be an x equals 2. Okay? So you can tell I'm going to be foiling for a while. Now, the ones that make me happy are these 0 ones, okay? So, get everything a 0 on the right side. So add 2 to these ones. I don't have to do nothing to the ones that say x equals 0, but that last one has a x equals 2, so I'm going to subtract 2 from both sides and get x minus 2 equals 0. So these single x's I'm going to put in the front. So I'm going to have an x times an x. And then I'm going to start putting my stuff in my parentheses. X plus 2, x plus 2, x plus 2, and then I have a x minus 2. So I didn't lie about foiling. Now, if you want to, what's this x times x going to give me? X squared. I'm going to put x squared right in the very beginning. I'm going to foil these 2 and them 2 at the same time. And y'all, what I'm going to actually do is I'm going to keep them in line so that y'all can follow me on these ones. So that'll be in these parentheses, and then that one in those parentheses. Now, I'll have to do it again just to add the like terms, but I'm going to foil it like this. So x times x is an x squared. X times 2 is a 2x. 2 times x is a 2x. 2 times 2 is a positive 4. Just be careful. This one does not cancel. Those are both positive 2's, okay? Now I'm going to start foiling this one. Now look here. These are conjugate pairs. Anytime you foil conjugate pairs, the 2 middle terms cancel out every time. Just like on the i's and the radicals one, okay? So here we go here. X times x is x squared. X times negative 2 is negative 2x. 2 times x is a positive 2x. And then 2 times negative 2 is a negative 4. All right, so I'm going to bring down my x squared. And y'all, in each of my parentheses, I'm going to take care of them terms in the middle. This one you add and get a 4x. But what happens on that one?
Yeah.
Those were canceled because these were conjugate pairs. All right, so let's see what we got. We got x squared plus a 4x plus 4. And then that one was what? X squared minus 4. The only time you'll foil conjugate pairs and get a plus is if they're imaginary, remember? Radicals and numbers like that are always going to be x squared minus. Well, hell. If we got that long more to go through next. So let me make some space. Now I'm not going to mess with that x squared in the front yet. So I'm going to still bring down my x squared. Now, all 3 of these got to multiply by both of these, okay? So this x squared times x squared is an x to the 4th. X squared times that negative 4 is a negative 4x squared. So that takes care of the x squared being distributed. Now I'm going to distribute the 4x. 4x times x squared is a 4x to the 3rd. 4x times negative 4 is a negative 16x. Then I do the 4. 4 times x squared is a 4x squared. 4 times negative 4 is a negative 16. So bring down the x squared. So now I'm just going to try to add like terms together in here. So the x4 comes down. Let's see, there's the x3, and that's only one, right? So I get a positive 4x to the 3rd. X squareds add together, but what happens to my x squared? Negative 4x squared, positive 4x squared. Those are going to cancel. What's next? Negative 16x, don't have that to add to, so bring down to negative 16x, and then minus 16. All equal to your 0. This one, every time I've been seeing it, you have the x squared term has been canceling on this, okay? Now, the hard part's done. All we got to do now is multiply x squared by everybody. So x squared times x4 is what? X6. So I'm just adding exponents. X squared times 4x to the 3rd is a positive 4x to the 5th. Anytime you distribute an x like this, you're just knocking all these exponents up by 2, okay? X squared times negative 16x is a negative 16x to the 3rd. X squared times negative 16 is a negative 16x squared, all equal to 0. But remember, they wanted me to find a degree 6. My highest exponent is a 6. Okay? So those are the tricks on those, is just, you got a lot of foiling. But the ones that equal 0, put them in front and distribute them at the end like a greatest common factor, okay? Oh, I'll pick up on these things on when we come back Wednesday. And I get a little hairy on Wednesday, so y'all be here. Any questions? Any of y'all driving to Fayetteville tonight? They're having a watch party in Bud Walton Arena or something like that. But that game ain't on till like 9 o'clock. Who's gonna be up there till 11:30, then come back? That's probably a 2-hour drive or more, right? And you know it's gonna be crowded and crazy. Then if you lose, they're gonna be throwing stuff and acting crazy then. All right, y'all. So I'll stop this video and I'll try to send this out as quick as I can. Monica, would you able to hear me all right online?